Figure 8.4, pointer operators, ampersand, and star. The ampersand operator is actually called the address of operator, and it allows you to determine the location of a variable in memory. And the star operator is called the pointer dereferencing operator, and when it's applied to a pointer, it gives you the value at the location in memory that the pointer points to. And we want to demonstrate these two operators for you in this example and also show you that these operators are actually complements of one another as well. Now, when I run this program, actually let's just go ahead and run it. We'll take a look at this output as we go through the source code, but separately we'll also run this program in the debugger so that you can look at the different variables that we're manipulating at actual execution time. So let's start with line 9 in the main function here, where we declare the integer variable a. A is going to store an int value, a whole number value. Let's assume we're on a 4-byte integer system, in which case a's values can range anywhere from in the range plus or minus 2 billion and change. Now separately we have a variable called aptr, which is a pointer to an integer. When you read declarations, you typically read them from right to left. So aptr is a pointer to an integer, and a pointer to an integer is a variable that stores the address of an integer variable in memory. So it indirectly references an integer value. Now neither of these two variables has been initialized yet, so at line 12 we assign a value to a. We assign the value 7 to a, and then at line 13 we're saying let's take the address of the variable a. So when you apply ampersand to a variable name in an expression like this, you're determining the location of that variable in memory. So we take that location and store it in aptr. Now the location of a is considered to be a pointer. Any memory address is considered to be a pointer, and you can only store memory addresses in variables that are declared to be pointers. Not only that, C++ is type sensitive, so when I take the address of a is a pointer to an integer because a is an integer, and you can only store a pointer to an integer in a variable that's been declared to be a pointer to an integer. So on the right side of this assignment, I have an expression that generates a pointer to an integer. On the right side, I have a variable that can store a pointer to an integer, and now aptr points to the variable a because of that assignment. Now at line 15 and 16, we're going to output the value of ampersand a, the value of a's address in memory, and we're going to output aptr's value. And it turns out when you output pointer values using cout, it displays them in hexadecimal notation by default. And the reason we're showing you these two things being output is just to show you that indeed the expression address of a and the variable aptr now have the same value. So let's look at our output window, and you can see that the address of a is, and this is the actual memory address where the variable a's value is stored in memory. And then aptr, which points to a, contains a's memory address. So we are seeing that indeed ampersand a now evaluates the same thing that was stored into aptr back at line 13. Now separately at line 17 and 18, we output the value of a, and we show you how to access the value that a pointer points to. And the way you do that is by quote-unquote dereferencing the pointer. And we do that with the pointer dereferencing operator, which is a unary operator that appears before the variable that's going to be dereferenced. And basically what this says is go to the location that a pointer points to and get me the value at that location in memory. Well, the value at that location in memory is the value of the variable a. So when I output the value of a and then the value of star aptr, you can see in the output window that in both cases I get the value 7. So a directly contains the value 7. A pointer indirectly refers to that value, and I can get to it by dereferencing the pointer. So star aptr evaluates to the value of 7. And in fact, going back to our declaration of APTR. You can read this, of course, as APTR is a pointer to an integer, but you can also read it as star APTR is an integer, and that gives you a hint of how to use that variable to get the integer value that the pointer points to. Now, finally, at lines 19 through 21, we demonstrate that ampersand and star are complements of one another. Now, these are both unary operators, and they're applied when multiple operators appear in the same expression from right to left. So what we're doing here is saying, let's first dereference a pointer, which moves us from the variable APTR to the variable a in memory. And then we're saying, give us the address of whatever that location is, and we're going to display that variable a's address once again. And similarly, we have this other expression here where we're first going to apply the ampersand. This says, give me the address of the pointer variable APTR in memory. And then I'm saying to dereference that pointer, which moves me from the pointer to a pointer back to a pointer, and that means I'm going to display the value that's actually stored in the variable APTR, which of course is the address of the variable a. And if you take a look here, you can see in the last two lines of output that once again we output the same memory addresses. Now let's just go ahead and run this in debug mode for a moment. And as we get into the debugger, we can look at the values of our variables in memory, and if we just reset this a little bit so we can see the code. So we see here that a has not yet been initialized, so let's just go ahead and step to the next line so we can see a being initialized. We can also see that APTR has not yet been initialized, and as we step, we can see that APTR now contains this memory address, and we can also see up here that the expression address of a has the same memory address, and when you expand the pointer value or the address of a expression, notice in both cases that it also shows you the value that the pointer points to, the value 7 in this example. So we can also hover over various expressions. We can see that the value of a is 7. We can see the value of a pointer, and we can expand that to see that it points indirectly to the value 7. So you get some nice little features from the IDE here. Of course, the expression ampersand a, when I highlight it, you can see that it's the address 0x and then a bunch of characters. That's the hexadecimal notation for the memory address. And again, if you compare what's in this little quick info box with what's showing down in the autos window, you can see that indeed the memory addresses for the address of a and the variable a pointer match up.